Hello students, this is the extra practice for 4.3, 4.4, and 4.5. I'm going to be explaining each one of the examples so that you can follow with me. Make sure that you try it first, so pause the video and then try it, then come back and see if you got it right. So before we start, remember that if it's outside, whatever is outside, we have gone through this already in class, but whenever it's outside of a parenthesis, of the square root, or of the absolute value, outside is related to y, and it follows the rule. When it's inside, it's related to x, and it does not follow the rule. It's the opposite, okay? When it's related to x, it's inside, and it's opposite. It doesn't follow the rule. The rule in here is multiplication, you will do division. So for all of them, if it's addition, instead of going to the positives, it goes to the negatives. If it's subtraction, instead of going to the negatives, it goes to the positives. If you're multiplying, you're going to divide x by the number that you have in there. And if it's multiplication with a fraction, if it's a fraction in here, then you will you will multiply by the denominator, okay? So that's gonna make more sense. And then in the next video, I'm going to do review of the mirrors or reflections. So also see that video so that you are more clear about it, okay? Okay, so in here, it's outside of parentheses. It doesn't have a parenthesis, so it's outside. It's related to y, and it follows the rule. If this is on the left, is a coefficient, it means multiplication. Related to y, remember. So this point is 1, 0, 0. This point is 1, 1, 1, 1. This point is 2 on x, 4 on y. So 2, 4. And this point is 3, 9. On the other side, you have -1, +1. This one is -2, +4. And this one is -3, +9. Again, outside, it's related to y, so we're only going to focus on the y value, okay, on the y value of all our coordinates. And so, for this first one, 0 times 2 is 0. So this one stays the same, 0, and 0 times 2 is 0, so it's 0 for y again. For this one, the x is going to stay as 1, but the y is 1 times 2, 2. So the new coordinate will be 1, 2. So it's 1, 2 right here. For this one, it's -1 for x, but then the y is going to be 1 times 2 is 2. So -1, +2. So all we're doing is multiplying the y values by 2. 2, 4. We'll multiply the 4 by 2 is 8. So the new coordinate will be 2, 8. So 2 on x, 8 on y, right there. And we're not going to bother doing the multiplication of 9 because that's going to be 18 and we don't have 18 squares. Now, if you do one side, you can even just do this one and just reflect it on the other side because parabolas always reflect, and it's going to be right here. And now that we multiply all the y's, we just draw our new graph. And that's it. So that's when it's outside. You multiply the y values and it stretches. That's why this is called a vertical stretch. Inside, multiplying by 2 is the opposite. Remember, inside is related to x, and do the opposite. Instead of multiplying, we divide. divide by 2. And it's the inside is always related to x, so what we're going to divide by 2 is the x values. Again, this is 0, 0, 1, 1, 4, 2, 9, 3, the other way around. Oh, so it's 2, 4, 3, 9. Sorry about that. On the other side is negative 1, 1, negative 2, 4, and negative 3, positive 9. Which ones are we going to focus? On the x. When it's inside, it's related to x. And so, now what we're going to do is divide the value of x. 0 divided by 2 is still 0. And that one stays the same, so right here. In here, 1 divided by 2 is 1/2. 1 divided by 2 is 1/2, and the 1 stays the same, so 1/2, 1. 2 divided by 2 is 1, so the new coordinate will be 1. 2 divided by 2 is 1, comma 4. The y stays the same, okay? So 1, 4 is right here. And then this one, the new one is 3 divided by 2. Well, 3 divided by 2 is equals to, how many times does the 2 go into 3? 1. 1 times 2 is 2. To get to 3, you have 1 more, and the denominator stays the same. So 1 and 1/2. For x is going to be 1 1/2, and the y stays the same. So 1 and 1/2, and the 9 stays the same right here. And for the other side, again, we can just do the reflection of that, because remember, parabolas are going to be always symmetrical. Oops, 1 1/2, so negative 1 and 1/2. And that's all. All you have to do is graph or connect the points. So this is called a horizontal compression. Okay, horizontal compression. Notice how outside is a vertical stretch, so the points grow tall. In here, it's a horizontal compression, so it gets also skinnier, but closer to y, but for different reasons. Okay. Number 3 and 4. A fraction outside, it means like division, okay? A fraction is a division. And so each point is, again, outside relates to y, okay? So this is 0, 0. This is 1, 1. And this is 2, 8. Negative 1, negative 1. And negative 2, negative 8. Again, when it's outside, it relates to y, and if it's a fraction, that means that we're going to divide the y values. That's why we say it's related to y. So highlight the y values just so you don't forget and you don't choose the x instead. So now, the 2 stays the same, but this is going to be 1/3 of that. So 1/3 of 8 is the same as 8 divided by 3. 8 divided by 3, we put it as 8 divided by 3. How many times does the 3 go into 8? 2 times. 2 times 3 is 6. How many more to get to 8? 2 more. And the denominator stays the same. So the new coordinate is going to be 2 for x and 2 2/3 for y. for this point. Oh, and how do you graph that? 2 on x, go 2 on x, and then 2 and 1/3, 2/3, right there. Okay, we divided the third square into 3 parts, and we move over only 2 of them. So that's my coordinate right there. For 1, 1, x stays as 1, and 1 divided by 3 is 1/3. Okay, 1 divided by 3, and you cannot simplify anymore. So to graph it, we're going to move 1 on x and 1/3 on y. For 0, 0, 0 divided by 3 is just 0, so it stays right there. So this is my first point, this is the second, and then that's from here, it goes down here. So it's a compression, vertical compression. This one is the same. -1 divided by 3 is -1/3. So it's right there, very close to the x-axis. -8 is the same as 8 divided by 3, but in this case it's negative. Negative divided by positive is negative. So -2 and 2/3, right? So -2 and -2 and 2/3, right there. So my new graph will go something like this. Okay, so let's go to the next one. Inside is related to x, and we do the opposite. Since it's a fraction, it means division, so the opposite is to multiply. And what are we going to multiply? The x values, okay, the x values. Again, let's put the dots in here, the coordinates. 2, 8, 1, 1, 0, 0, -1, -1, and -2, -8. Inside is related to x, so highlight the x, because otherwise we might forget which one are we working with. And then we start working with them. 2 times 3 is 6. So the x is not a 2 anymore, it's a 6. And the 8 stays the same. So we're going to graph 6, 8. This point becomes 6, 8, right there. Okay, this point went all the way over here. So this is called a horizontal stretch. Oops, horizontal stretch. Okay, it went this way. This point, 1 times 3 is 3. And the y stays the same, so 1, 2, 3, and 1. Again, this point stretched over here. 0 times 3 is 0. That one stays the same, right? 0, 0. So on this side, it's going to go like this. On this side, well, it's going to be the same pattern, 3, 1, so it's going to be -3, -1. So it's going to stretch over here. But if you're not sure, just multiply. -1 times 3 is -3, and the y value stays the same. So -3, -1, right there. See how it's stretched away from x? I mean, away from this. Okay, and this one, -2 times 3 is -6. The -8 stays the same. So -6 and -8 right here. And so my graph goes something like this. Okay, so this is a horizontal stretch, and you can see that it's stretching. This is a vertical compression. I forgot to write it down. Vertical compression. I think that's how it's spelled. If not, I'm gonna have to go back to spelling school. Okay, so that's, notice how I'm doing the same thing outside when it affects the y value, inside when it affects the x value, the same values I'm using, but look at the what it does. Vertical compression, a horizontal stretch. On top is a multiplication on both cases. This is a vertical stretch, and on here is a horizontal compression. Okay, so compare those so that you can look at the difference and similarities. Okay, similarity in the coefficients, but then inside and outside the different effects. Okay, now let's do, I'm going to use pink for addition and inside, outside and inside, but now I'm using the absolute value. Remember that the matter graph is just like if we didn't have anything, just the y equals and something else. Once I'm adding or subtracting, that's translations. When we have a negative on the left of the x, on the left, those are mirrors or reflections. When we have multiplication on the left also of x, that's depending on if it's outside or inside. Okay, and then also fractions, that's multiplication or division depending on where they are. Okay, okay, so it says to graph in pink because I'm going to use the same graph for two of them. So in pink, if we have the absolute value and we have to add 3, that means that our matter graph is the absolute value of x, add 3 to each point. Outside, addition just means follow the rules. So if you add, outside is related to y, so that means that it's going to go up. Inside, adding, it's related to x, so it's either left or right. But this one does not follow the rule. Instead of going to the positives, it's going to go to the negatives. Okay, so have that in mind. So we have this graph right here. All you have to do is add 3 to each point. So we start at 0, 0, 1, 2, 3 right here. If you want, you can see that there is a pattern and you can just do the dots like this because it's just diagonal and do your line. Or you can just count for each point, 1, 2, 3, and draw the point, the new point. 1, 2, 3, and draw the point. 1, 2, 3, and draw the point, and so on. Same here, 1, 2, 3, draw it. 1, 2, 3, 1, 2, 3, 1, 2, 3, and just draw the lines. Okay, so that's gonna be my new graph if we have this translation. So it's a vertical translation. Translation. On this one is a horizontal translation. Horizontal translation. So we're going to move each point 3 spaces to the left, and it doesn't matter where you start. So 1, 2, 3 is positive, but you go to the negatives. 1, 2, 3, 1, 2, 3, 1, 2, 3. This one, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so you draw it right there. Then it says to use the same graph, just because of space, in blue, I'm going to do the mirror. So now forget that you have this one and this one, okay? Ignore the pink one. We're going to do the mirror for the original one. So when it's outside, it's like when you go outside camping. You don't have a mirror to look at yourself and you want to brush your hair. So outside is like you have your hair, you don't know if it's messy or not. And so you want to go and look, but you don't have a mirror, go to the river or lake. You're outside, then the mirror is on the lake, okay? And so your reflection is going to go below the river or the water, okay? So the same here. This stays where it is, but this reflects over here. 1, 2, then you count from the line of reflection, which is your x-axis. 1, 2, so 1, 2. 1, 2, 3, 1, 2, 3. So all the points are just reflecting the same amount of spaces, okay? And then on this side, it reflects right here, right here, right here, right here. See, just like that little monita did. For the reflection inside you're inside of your house, you want to look at yourself. So if you're over here, you want to see if you're greñuda. The mirror is on the y-axis or the wall. Then your reflection is going to be on the other side of the wall, okay? So this is my mirror. Mirror on the wall. So this point goes over here, 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 and vice versa. Whatever is on the left goes to the right, and whatever is on the right goes to the left. In this case, just because of the absolute value, they're even symmetrically, no, even symmetry, it has even symmetry, then it stays on the same one. It looks exactly the same as the mother graph, okay? Something that I want you to look at is the notation of the function. In here, this one say y equals, and then whatever your equation is, or function. In here, we wrote it as f of x, but it's the same thing, okay? If you put f of x or y, it's still a function, okay? F of x, f of x, f of x. But then look at these last ones. In here, this, if it was in with the equation, the entire equation, it would look like this. F of x or y equals, this is a square root. So we will have the square root of x minus 5. So this and this is exactly the same. Or y equals the square root of x minus 5 also is the same, okay? So having y or f of x is the same. We have the equation. In here, it doesn't specify what the equation is. It's just saying, to this graph, to this function, take away 5, and the 5 is outside, okay? So it just means whatever the graph is, whatever the mother graph I'm giving you, just take away 5. Because it's outside, it's related to y, and it follows the rule. When it's on y, negative means going down. So all you have to do for this mother graph is just go down 5 spaces. So this point is going to go 1, 2, 3, 4, 5, and just draw the dot in there. This point, 1, 2, 3, 4, 5, right there. 1, 2, 3, 4, 5, right there. And draw your new graph. Okay, now for number 10, same thing. This is not specifying the cubic. Let me show you how it would look. It would look f of x equals, then you will have the cubic root, and it's going to be x minus 5. It means that you're subtracting 5 inside of the parentheses. Inside is related to x. Subtraction means just translation. So if you're subtracting, instead of going to the negatives, you go to the positives on x, okay? On x, because it's inside. Inside, always related to x. Outside, always related to y. So now I'm going to move every point 5 spaces. So 1, 2, 3, 4, 5, right there. This point, 1, 2, 3, 4, 5, right there. This point is 1, 2, 3, 4, 5, right there. This point, 1, 2, 3, 4, 5, right there. And the last one, 1, 2, 3, 4, 5, right there. And then we just connect the points. Okay, so this is my quadratic horizontal translation. Not cubic, I'm sorry. Cubic because it has the cube. quadratic will be like the letter U, the parabola. Okay, so hopefully this will help you review more of the translations that we have been learning separately. This is just the entire thing, and if you can please give us a thumbs up, subscribe around here. This is the next video in this lesson, in this unit, and this is the entire unit, so the entire playlist. Keep practicing and have fun.